For Lesson 5-6, we're graphing proportional relationships, and there are no vocabulary words, but you want to make sure and always take a look at the examples given in the book to get an understanding of what we're talking about here. As you can see from the What You'll Learn section, we are identifying proportional relationships and analyzing proportional relationships. Okay, so as we look at the example here, we're talking about um, center A and center B for the party and showing on the graph as far as the two locations there. Notice that for center A that the rate is not constant, so the relationship between the cost and the number of guests is non-proportional. Okay, it is a straight line that does not pass through the origin, which is something that you'll learn in algebra, but we can talk about it right now as well. When it passes through the origin, it's going to be a direct variation. Okay, so in this case, it's not a direct variation. Sorry about my handwriting here, but it's not a direct variation because it does not pass through the origin. So, sorry about this. Right here, it's passing at $400. Okay, so there's that upfront cost of $400 right away. This other example right here, center B, is a direct variation because it does pass through the center. So we have the rate is constant and it is proportional. So the graph is a straight line that does pass through the origin, making it a direct variation. Okay, so if we scroll down to the bottom here of this page, that ends the problem there. But let's take a look at the next page for an example. Okay, so determine whether each relationship is proportional by graphing it and then explain your reasoning. So the black mamba is the fastest snake in the world, and the table shows that the distance the snake travels for different times. And so in this case, it might just be logical that if 0 time has passed, then 0 meters is how far it will travel. So it passes through the 0, 0, and then for as far as seconds, it looks like 1 for 5, 2 seconds for 10, 3 seconds for 15, and so whether you graph it or whether you look at the ordered pairs or the table here, it is proportional, and that constant of proportionality is 5, meaning that every second it increases by 5 meters. And since those ratios are constant, the relationship is proportional. It is actually a direct variation since it passes through the origin 0, 0. For letter B here, a candle is 20 centimeters tall, and then it burns at a rate of 2 centimeters per hour. So notice this table right here, 0 hours it burns, it's going to stay at 20 centimeters. 1 hour is 18, 2 hours is 16. Notice that it's going down by 2 centimeters each time. Okay, and even though it is a constant decrease of 2 centimeters each time, when we look at those ratios right here, 18 divided by 1 and 16 divided by 2, 16 divided by 2 is 8 over 1, and then we don't get that same constant of proportionality. So we are going to say that those ratios are not constant and that the relationship is non-proportional. Let's take a look at the example given here. 2 to 6, 4 to 8, 6 to 10, 8 to 12, and 10 to 14. Okay, is the cost proportional to the number of tickets? So we have 6 over 2, which means that's 3. And then right away we notice that $8 for 4 tickets, it jumps down to $2 a ticket. So we're going to say that that's we can continue, but we already know that it's not proportional. Okay, we can also say that it's that's all I'm going to say about that. Sorry. Take a look at 1B. 2 hot dogs is $6. That means 6 divided by 2 is $3 a hot dog. And then if we take $12 for 4 hot dogs, 12 divided by 4 is also 3. and 18 divided by 6 is also 3, 24 divided by 8 is 3, 30 divided by 10 is 3. Yes, on 1b it is proportional because it's the ratio is constant there. So we could say that the constant of proportionality is 3, in this case $3. We can also say it's a direct variation because if you buy 0 hot dogs, it's going to cost you $0. All right, so that's example 1 there. Let's take a look at example 2. Here at the top, analyzing proportional reasoning. When two quantities are proportional, you can use a graph to find the constant of proportionality and analyze the points. The graph of every proportional relationship passes through the point 0, 0. Again, that's called direct variation. And then the 1, comma r, that point on the graph there, tells you the constant of proportionality. So let's take a look at an example here. The length of the stretch of a spring is proportional to the weight in grams. And it says to find and interpret the constant of proportionality. So it says here to use the point 525 on the graph, and we have the length of the stretch is equal to 25, and the weight is equal to 5. So the constant of proportionality here is 5, okay? And that's 5 millimeters of stretch per gram of weight. And it says explain what the points 0, 0, 1, 5, and 525 represent. Well, obviously 0, 0 represents the length of the stretch in 0 millimeters when no weight is attached. Obviously it's not going to stretch if there's no weight attached. However, 1, 5 represents the length of the stretch of the spring, which is 5 millimeters, when 1 gram of weight is attached. And the point 525 is the stretch, which is 25 millimeters, when a 5 gram weight is attached. And notice up here that my x-axis is the weight. Okay, so one weight would be 5 millimeters of stretch, which is my y-axis label. Okay, if something 7 grams was attached, a weight was 7 grams attached, the stretch would be equal to 5 times that, which is 35. So interpreting those graphs is important. Let's take a look at the bottom of page 214 for the got it problem. Keith plants a seed every 3 days. After the seed sprout, he measures the height of the plant. Every 3 days after the seed sprouts, he measures the height of the plant. The graph shows the result. Find and interpret the constant of proportionality. Okay, so we have on the 3rd day, it is 6. Okay, on the 6th day, it is 12. On the 9th day, it is 18. So we have these ratios that we can find the constant of proportionality. So 12 and 6 and 18 and 9. Sorry about my handwriting, but in each case the constant of proportionality is 2. So what does that mean? Well, that means that 0, 0, 0 days mean that the height is 0. But on the 1st day, it's going to be 2 millimeters tall. On the 6th day, it's going to be 12 millimeters tall. And on the 21st day, it's going to be 42 millimeters tall. Okay, so hopefully that's enough to get you started on this section. And if not, please suggest or please request a Google Hangout and we can go over some more examples.